Here are 3 problems you may try. You may pause the video while you attempt the 3 problems and resume the video when you're ready to hear the answers. Let's review the answers. In number 1, the product of those 2 binomials is 4x squared plus 17x minus 15. In number 2, the product of those 2 binomials is x squared minus 8x plus 12. And in number 3, the product of those 2 binomials is x squared minus 81. Let's review the process to determine the product of the 2 binomials for number 3. The first term in the first binomial is multiplied by each term in the second binomial, and the second term in the first binomial is multiplied by each term in the second binomial. The sum of 9x and minus 9x is 0x, and 0 times anything is 0, so we can rewrite this as x squared minus 81. Here are 2 problems you may try. You may pause the video while you attempt the problems and resume the video when you're ready to hear the answers. Let's review the answers. The directions state: the area of the shaded region is presented as an algebraic expression. Determine the dimensions of the shaded region that would produce the area that is presented. In number 4, the dimensions are and in number 5, the dimensions are. Let's review the process used to determine the dimensions for the shaded region in number 5. Notice that the algebraic expression has 3 monomials that comprise it. One of the monomials is an x squared term that has a coefficient of 1. That indicates to us that there must be some portion of the shaded region that has the same dimension for its base as it does for its height. This appears to be its square, so this can be 1x, and this could also be a 1x. The product of 1x and 1x is 1x squared, and that is the first term in the algebraic expression that represents the area of the shaded region. Rather than include a 1 for each of those coefficients, typically we leave it as just x, and it's assumed that the coefficient is 1. The next thing that should be noticed about this algebraic expression is that this constant term, meaning it doesn't have a variable as part of the term, is a positive 64. That indicates to us that some part of the shaded region has an area of 64. What we should do is we should look at the factors of 64. Then we can look at the coefficient of the variable term in the algebraic expression that has an x to the power of 1. Notice the coefficient is 20. So what we're looking for are the factors of 64 whose sum is 20. The 16 and 4 has a sum of 20. Therefore, those are the factors that we're going to use. The base of this rectangle would be 16 and the height would be 4. That tells us that the area of this rectangle is 64, and that's what we wanted. Since the base of this rectangle is 16, the base of this rectangle must also be 16, and since the height of this rectangle is 4, that means the height of this rectangle is 4. We could check our answers. Let's determine the area of this rectangle. We'll also determine the area of that square, and we'll determine the area of this rectangle. We can determine the total area of the shaded region by adding the areas of the parts of the shaded region. The sum of 16x and 4x is 20x. We can compare this expression to the expression that was presented. It is identical, therefore we have the correct dimensions. We could check our answer algebraically. For the base of the entire shaded region, we could use the expression x plus 16, and to represent the height of the entire shaded region, we could use the expression x plus 4. The area of the entire shaded region could be found by multiplying the base times the height. The base is x plus 16 and the height is x plus 4. And again, our check is successful. Here are two examples. The directions state that a trinomial expression is presented. The trinomial expression is the product of two binomial expressions. Determine the two binomial expressions whose product is the trinomial expression that is presented. In example A, the first thing that should be noticed is that there are three monomial terms that comprise this trinomial. One of the monomial terms is x squared, and it has a coefficient of 1. That monomial term, because it has an exponent of 2, is what is referred to as the quadratic term. The second monomial term is a plus 17x. That x has an exponent of 1. Therefore, that term is referred to as the linear term because the exponent on the variable x is 1. The third term is a plus 70. That is not a variable term. It is what we refer to as a constant term. Its value does not change regardless of the value of x. Recognizing that the coefficient of the quadratic term is 1, that indicates to us that the first term in the first binomial will be 1x, and the first term in the second binomial will also be 1x. The product of the coefficients of those two terms would be 1, and that is the coefficient of the quadratic term in the expression. Notice that the constant term is positive. That indicates that the factors that we're going to use in the two binomials whose product is that trinomial are either going to be both positive or both negative. The coefficient of the linear term is plus 17. That tells us that the two factors of 70 that we're going to use are going to be both positive. Let's determine the factors of 70. We'd like to determine the factors of 70 whose sum is equal to plus 17. The 10 and the 7 are the factors of 70 whose sum is plus 17. So those are the factors that we're going to use to complete these two binomials. The second term in the first binomial can be plus 10, and the second term in the second binomial can be plus 7. To check our answer, we can determine the product of those two binomials. Compare this expression to the expression that was presented, and we notice that it is equal. Therefore, our check is successful. So the two binomials whose product is the trinomial that is presented are the quantity of x plus 10 times the quantity of x plus 7. Example B. Again, notice the trinomial expression has three monomials that comprise it, and the first monomial is a quadratic term because the exponent is 2. The second monomial is a linear term because the exponent is 1. It has a positive coefficient of 20. And the third term in the expression is a constant term plus 36. Since the quadratic term has a coefficient of 1, the first term in the first binomial will be 1y, and the first term in the second binomial will also be 1y. Now we want to determine the factors of plus 36. Notice the constant term is positive, therefore the factors of 36 that we're going to use are going to be either both positive or both negative. Notice that the coefficient of the linear term is a plus 20. Since the coefficient is a positive, we're going to use the factors of 36 that are both positive whose sum is plus 20. Let's look at the factors of 36. The factors 2 and 18 have a sum of plus 20, so those are the factors that we're going to use to complete these two binomials. The second term in the first binomial can be plus 2, and the second term in this second binomial can be plus 18. We can check our answer by multiplying those two binomials. The sum of 18y and 2y is 20y. Compare that expression to the original expression. It is identical, therefore our check is successful. And the two binomials whose product is the trinomial that is presented are the quantity of y plus 2 times the quantity of y plus 18. Here are two more examples. In example C, notice the quadratic term has a coefficient of 1. That indicates to us that the first term in the first binomial is going to be a 1y, and the first term in the second binomial is going to be a 1y. Notice the constant term is a positive 27. Therefore, the factors that we're going to use to complete the two binomials are going to be either both positive or both negative. Notice the coefficient of the linear term is a negative 12. That indicates that the factors of 27 that we're going to use to complete those two binomials are going to be both negative. Let's look at the factors of 27. Since both of the factors will be negative, we only need to determine the negative factors that would produce 27. Notice the factors negative 3 and negative 9 would have a sum of negative 12. Therefore, those are the two factors that we're going to use to complete these binomials. The second term in the first binomial can be negative 3, and the second term in the second binomial can be negative 9. Let's check our answer by determining the product of those two binomials. The sum of minus 9y and minus 3y is minus 12y. Compare that expression to the expression that was presented. It is identical, therefore our check is successful. And the two binomials whose product is the trinomial that is presented is the quantity of y minus 3 times the quantity of y minus 9. In example D, notice the trinomial expression contains three monomials. The quadratic term in the trinomial has a coefficient of 1. Therefore, the first term in each of the binomials will be 1x. Notice the constant term is plus 56. That indicates to us that the factors that are going to be used to complete these two binomials are either going to be both positive or both negative. Notice the coefficient of the linear term in the trinomial is negative 57. Since the coefficient is negative, that indicates that the factors of 56 that we are going to use to complete these two binomials are going to be both negative. Let's look at the factors of 56. We want to determine the factors of 56 whose sum is negative 57. The factors negative 1 and negative 56 have a sum of negative 57. So those are the two factors that we're going to use to complete these binomials. The second term in the first binomial can be negative 1, and the second term in the second binomial can be negative 56. We can check the answer by multiplying the two binomials. Compare that expression to the expression that was presented in example D, and it is identical. Therefore, our check is successful, and the two binomials whose product is the trinomial that was presented is the quantity of x minus 1 times the quantity of x minus 56.